Alright class, welcome to this lesson on the z-test for a proportion. So last lesson we looked at a t-test for the mean, and we used that when the sample size was less than 30. For lesson 2 we looked at the z-test for the mean, and we used that test when the sample mean was greater than 30. So this time we're going to switch back to the z-test in order to deal with proportions. So there are a lot of situations that involve proportions. When I mean proportions, I mean numbers that can be expressed as a fraction, decimal, or percent. So generally, it's sort of like probability, where the number is between 0 and 1. So some examples of proportions are 59% of consumers purchase gifts for their fathers. That involves a percent and therefore a proportion. About 8 in 10 people over 21 said they have entered a sweepstakes. This is a ratio or fraction, so therefore it involves a proportion. And the last example, about half of all Americans buy generic products. So again, another percent or fraction or decimal, so therefore a proportion. So what we're going to do is we're going to focus on just these kind of proportions, and we're going to be using a hypothesis test, but in order to do that, first we're going to consider the population proportion as a binomial variable. So recall from chapter 5 we looked at the binomial distribution. So we're going to consider this proportion as a binomial experiment where there are two outcomes. Remember that the bi prefix means two and nomial means category. So we're looking at two outcomes, and we usually call them success and failure. The probability of success, remember, from trial to trial remains the same, so it remains constant. And that's what defines a binomial experiment. And there are a few more requirements, such as, each trial is independent and such. So if you recall from the binomial distribution, there are a couple formulas to find the mean and the standard deviation. So I went ahead and listed them because we're going to need these formulas in order to derive the z-test for the proportions, the test value. So we're going to need that in conjunction with the generic formula for the test value. So the test value is calculated by taking the observation minus the expectation divided by the standard error. So for example, in the z-test for the mean, we said that the z-test value is equal to the observed mean value, which is the x bar, and then minus the hypothesized or expected mean value, which is mu, over the standard error. And we said that the standard error was given by the sigma over square root of n. So that would be an example of using the generic test value to derive like a situation, to derive a test value. So what we're going to do to derive the formula for proportions, the test value, we're going to be using the formula for calculating the z-score, as well as the binomial distribution formula. So we're going to be doing a substitution of the binomial formula components into the formula for the z-score. So when we do that, we get a formula, we get a form that looks like this. So we have z equals x minus np over square root of npq. So technically this is sort of like a sort of what we're looking for, but we're gonna clean it up a little bit. We're gonna do a couple more things to it. So we're gonna divide the numerator and denominator by n. So I'm going to do that in this step. So I'm going to divide the numerator individually, each of the numbers individually, by n. Oops, this should be n here. And then the denominator by n. Now recall that that this n is outside of the radical. If I bring this n inside the radical, it becomes n squared. And the reason, if you forget with that fact, is because if I have a 3 outside the radical and I pull it inside, it becomes 3 squared, because the square root of 3 squared is just 3. So if I pull it back out, it just becomes 3. So if I had like a square root of 9 and I want to pull that out, well, that's just going to be 3. But if I pull it back in, it has to become 9 again. So if I bring the n inside, it's going to be n squared. So that's what I'm going to do in the next step here. So we have x over n minus p over square root npq over n squared. So now one of the n's cancels. And we're going to rename this term here p hat. So this, we're going to rename this p hat, which is the sample proportion. And then remember that the p is the hypothesized proportion. So now we have z is equal to p hat minus p over square root of pq over n. And this is our formula for the test value. So now we got the formula for the test value. So notice that we have observation minus hypothesized proportion divided by standard error. So this is the formula, so in a nicer, cleaner format. So we have the z-test equals p hat minus p over square root of pq over n as derived. So again, this is the formula for the test value. So recall that x is essentially, the number of people that satisfy our characteristics. So number of objects or people satisfying, or we could say with a given characteristic. So we'll say number of objects with a given characteristic. So for example, if you're looking at the characteristic of, smoking, then the number of people that smoke would belong in the numerator, divided by the total number of people, because n, if you recall, is the total number of objects or people. All right, and then we recall that the q term here, in order to calculate q is, so if you can think of p as the probability of success, then q is sort of like the probability of failure, and so you do 1, so you say kind of like failure, which is 1 minus p. All right, so sometimes we need to calculate the p hat. However, there are times where it is given and we don't have to calculate it, depending on the problem. So since we are performing a z-test for proportions, this means that the method of hypothesis testing do not change from the methods we use in section 8.2. The only methods that change, or the only thing that changes in the z-test for proportions is the test value formula that we found. All right, so looking at the following problem, we are gonna, for the problems that are in this lesson, we're going to do the traditional method as well as the p-value method in order to remind you of how to do both ways. So a researcher claims that based on the information obtained from the Centers for Disease Control and Prevention, 17% of young people ages 2 through 19 are obese. To test this claim, she randomly selected 200 people ages 2 through 19 and found that 42 were obese. At alpha equals 0.05, is there enough evidence to reject the claim? So clearly we're looking at a proportion because of the fact that they give us percentages or fractions here. So we got a percent, and that's our claim. So step 1 is to identify our claim and our hypothesis. So we have H0 and HA. So if we look at the 17% statement, it says that 17% of young people ages 2 through 19 are obese, which means that we have the proportion is equal to 0.17. So we're writing that as a decimal here. And this is our claim. And remember that the null hypothesis is a statement of equality, so this has the equal sign. And we're going to do the opposite of that, which is not equal to. So since they don't mention that it's greater than or anything, we're just saying not equal to. And this is a two-tailed test based off of the fact that it's not equal to. All right, so the p-value, the first step for the p-value is the same as it is for the traditional method. So I'm just going to say, look at the other way, or ditto, same thing. So now, for step 2 for the traditional method, we need to find the critical value. So to find the critical value, we're doing a two-tailed test, which means that we need to look at alpha divided by 2. So alpha in the problem is 0.05. And so we need to divide it into two tails. So this is our area on each side. So we need to look this up in the z-chart. Recall that since we're doing a two-tailed test, we're going to have two critical values here. So we're going to have a plus or minus version. All right, so we're going to go into the lookup and so let's look at up here. So 0.025. So this is the value in the chart. So this is about negative 1.96. If you look at the values here, negative 1.96. So, and we have a plus or minus version of that. So we have those two numbers. All right, so the next step is to find the test value. We'll call it TV. And that's the formula that was given earlier in the video. So we have this. So we'll need to calculate the p hat as well as the q. So we'll do this up here. So if you look at the problem, it says that to test the claim, she randomly selects 200 people. So that's her n. And found that 42 were obese. So that's her x. So the p hat is 42 over 200, which is 0.21. Now to find our q, recall that you got to do 1 minus p to find the q. So we're going to do 1 minus p, which is 1 minus 0.17, or 0.83. All right, so now we got our two values. We can go ahead and plug them in. So we got 0.21 minus 0.17 over square root of 0.21 minus 0.17, or times, sorry, this is 0.17 times q, which is 0.83, divided by 200. All right, so plugging into the calculator, we get about 1.51. All right, so that's our test value. So this is our z test. So now what we're going to do is we're going to draw the curve. We're going to draw a quick curve here. And then we're going to label the test value as well as the critical value. So labeling the test value here first, that is about 1.51. So around here, so I'll call that 1.51. Next, we're going to label our criticals, which are 1.96. negative 1.96. And we're going to shade our rejection regions. So clearly we're outside of our rejection regions, which are given in red, so therefore we fail to reject. So step 4, we fail to reject the null hypothesis. So now step 5, we're going to summarize our results. So this means we do not have enough evidence. So there is insufficient evidence at the 5% level of significance to, now our claim belongs to our HO, which means we're going to say reject here, to reject the claim that. And then if you recall, it says that the claim was that 17% of young people 2 through 19 are obese. Alright, so that looks like that's the traditional method. So now we're going to basically do this with a p-value method. So we're going to do step 2 here, which is step 2 for the p-value method is finding the actual test value, which we already did in step 3. So therefore I will just repeat it here. So the z-test was about 1.51. Now step 3 in the p-value method is to find the p-value. So what we're going to do is we're going to label the curve, and we're going to label our 2 z-tests. Since we got a z-test of 1.51, this means we have a positive version and a negative version when we're doing the p-value. So we are trying to find the p-value here, so I'll label it a different color so that we're not confusing that with a rejection region. We're just doing the p-value. So in order to do the p-value, you need to look up the area for both of these and then add them together. I'm just going to find the area for one of these and then double it because it's the same on both sides. So I'm going to look up the area for negative 1.51. So looking up the area for negative 1.51, we have negative 1.5 and 1 for the z. So therefore, the area is 0.0655. So we know now that this area is 0.0655, and this has to be the same, 0.0655. So we can simply calculate our p-value by doubling that number. So doubling that number gives us 0.13. So this will be 0, 1. So it should be 0.1310, about there. So this, for step 4, when we make our decision, what we do is we compare the p-value that we just calculated to alpha. So here it's greater than alpha, which means we fail to reject. So step 5 is the same as it was for step 5 of the other guy, of the traditional method. Alright, so let's look at another problem to give you the idea. In fact, we're going to be doing both methods here, again, to make sure that you understand the difference between the two methods. So the Gallup Crime Survey stated that 23% of gun owners are women. A researcher believes that in the area where he lives, the percentage is less than 23%. He randomly selects a sample of 100 gun owners and finds that 11% of the gun owners are women. At alpha equals 0.01, is the percentage of female gun owners in his area less than 23%? So we want to see if the area is, the number of female gun owners is less than 23%. So we'll say that that's our claim. So for step 1, we have our hypothesis. So it says less than 23%. So that means that less than 0.23, which means that since it's a statement of inequality, that belongs to the HA. So we're going to say that this is we're going to say, let me erase this. We're going to say this is as P. So P is less than 0.23. And that'll be our alternative hypothesis. And then we can say that the null hypothesis equals 0.23, or you can say greater than or equal to the direct opposite. All right, so either one is fine. Regardless, this is our claim. And since it's less than, we're looking at a left-tailed test. All right, so it says that we select a sample of 100 gun owners, so that means our N is 100, and 11% of the gun owners are women. So here we don't have to calculate the p hat because they give it directly to us, 11%, which is 0.11. So no need to calculate that. However, we still need to calculate the Q for the formula. So the Q is 1 minus the P, and the P is 0.23. So this will give us 0.77 per Q. All right, so now again, the p-value is going to be the same as it was for traditional, but let's do the step 2 first. So step 2, we're going to again do the critical values. So to do that, since we're doing a left-tailed test, all we need to do is look up alpha. We don't need to look up anything else. So we're going to simply look up 0.01 and get our critical value. Now, since it is a left-tailed test, that means we're going to have a negative number for our critical value, and there are no positives for the criticals. So looking up 0.01, this seems to be about here. So this is about negative 2.33 is our Z critical. All right, so now we got step 3, which is our test value. So this is where we do the calculations. So we got Z test equals, we have our p hat, which they mentioned earlier, 0.11. So we have 0.11. And I'm simply going to write down the numbers. I'm not going to rewrite down the formula. So we got 0.11 minus the p, 0.23, divided by square root of PQ. So P is 0.23 times Q, which is 0.77 over, we got a total of 100 gun owners, so over 100. All right, so plugging this into the calculator, we get about negative 2.85. All right, so now that we got the test value, we need to make a decision. So I'm going to draw the curve real quick, and I'll do it over here. So just a small curve, nothing too crazy. So we got our negative 2.85, and I'll do that in I'll do the p value or the test value in blue. So negative 2.85 is about negative 3. And we have our critical value at negative 2.33 here and here. So now we're going to shade our rejection regions. Oops, I don't have a positive 2.33. This is only a one-tailed test. So we're going to shade this side here for the left-tailed test because we only have a left region. And we can clearly see that we are looking at the case where we are in our rejection region. So since we are inside our rejection region in red, we actually reject. So step 4, we reject the HO. So that means that we have enough evidence. So there is enough evidence at the 1% level to, and then our claim belong to our HA, so that we're going to use the word support here instead of reject, to support the claim that 23% of gun owners, that less than 23% of gun owners are women. All right, so now we're going to walk through the p-value method real quick. So the first step of the p-value is the same as it was for the traditional method. So step 2, recall, is to do the test value, which we're just going to reiterate the test value number that we got earlier. Now step 3 is to find the p-value. So we're going to quickly draw a curve what we're looking at here. Now since we are doing a left-tailed test, we only got one test value, not two. So we're going to label our test value negative 2.85, somewhere around there. And we need to find the p-value, which is the area there for the left-tailed test. So we're going to look this up on the z-chart and we'll get our p-value for that area. So all right, so looking up negative 2.85, we get an area of 0.0022. So we have a p-value equals 0.022. So now our step 4 in our decision making, we say that the p-value is less than so we say it's less than alpha. So this is going to be less than alpha. This should have 2 zeros here. There should be another 0 there. So this is less than alpha. Let me just erase that and write the 2 zeros. So 0.0022. So it's less than alpha, so therefore we reject. So step 5 is going to be the same. All right, so now I want you guys to go ahead and try the following problem using the traditional method and the p-value method. And then we'll come back and actually give it a try. And I'll show you what the solution is. All right, so now looking at the problem, we have a statistician read that at least 77% of the population opposed replacing dollar bills with dollar coins. To see if this claim is valid, the statistician selected a random sample of 80 people and found that 55 were opposed to replacing the $1 bills. At alpha equals 0.01, the tester claimed that at least 77% of the population are opposed to the change. All right, so going straight to the hypothesis, so we have H0, HA, we see that it says at least 77% are opposed to the change. So at least is greater than or equal to. So that means that P is greater than or equal to 0.77. And this belongs to the HO because it's an equal sign. And then we're going to reverse this and we have less than 0.77 for HA. And here, this is our claim. And here we can tell that it's a left-tailed test because it's pointing to the left, the inequality. So left-tailed test. So now step 2 is the critical value. So since we're doing a left tail test, we only need to look up alpha, which is 0.01. And if we do that, we get a critical value, which was the same critical value that we got earlier over here of negative 2.33. All right, step 3 is to calculate the test value. So we have z test equals, so we need to find our p hat. So in this example, they said that we have 80 people, so that's our n. 55, that's our x. So we need to calculate p hat. So p hat is equal to 55 out of 80. And we need to calculate our q as well, which is 1 minus p, and p is 0.77. So this will be 0.23. All right, so I'm going to go ahead and plug p hat and z test into the calculator. All right, so went ahead and plugged in the numbers into the calculator. So I got the p hat, and I went ahead and plugged everything into the z test, and you should get negative 1.75 for the test value. So now what we're going to do is we're going to draw the curve and label our test value and our critical. Since we are looking at a left-tailed test, this means we only have the one critical. So I'm going to say 0. I'm going to focus on the left side. So we got negative 1.75 for the z test. Let me do it in a different color. And we're doing the critical in red. Oops. So that's a negative 2.33, and we're shading to the left of that, and that's a rejection. So it seems like we're outside of the rejection region, so therefore we're going to fail to reject. So step 4, we're going to fail to reject the H0. So then in step 5, we'll just say, for our summary, there is insufficient evidence, or there is not enough evidence and we're talking about the 1% level. And notice that our claim belonged to our HO, so we're going to use the word reject. Let me erase this real quick. To reject claim that, and our claim was that at least 77% of the population are opposed to change. Percent of the population are opposed. All right, so now if we look at the p-value method, step 1 is the same. Step 2 is our test value. So recall that our test value was calculated already, so we're going to say z test, it's negative 1.75. So now step 3 is our p-value. So we're going to draw the curve out, and we're going to label the z test. So which is negative 1.75. So we're going to shade that region. To find our p-value, we need to look this up. So we're going to look up negative 1.75. So negative 1.7, 5. So that's 0.0401. So that's our p-value. So the p-value is equal to that, and that is actually greater than our alpha, so therefore we fail to reject. And therefore step 5 is the same. All right, go ahead and try this following problem, and we'll come back and show you the solution. All right, so let's look at the solution to the problem. So let's go straight to the hypothesis statement. So we're looking at, is there enough evidence to support the attorney's claim? And the attorney's claim is that more than 25% advertise. So we have age 0, and more than is greater than. So that means that we're going to put that in our alternative. So we're going to say that P is more than 0.25. And then we're going to reverse it and say less than or equal to, or we could just say equal to. Either one is fine. I'm just going to go ahead and say less than or equal to. So just to do the exact opposite. But if you wrote equal to, that would have been fine as well. So this here is our claim. And we're looking at a right-tailed test here. Now, since we are looking at a right-tailed test, we need 1 minus alpha. So 1 minus 0.05. So we're going to look up 0.95 and get our critical value. Now, since it's a right-tailed test, we're going to be looking at a positive value only. So looking at 0.95, we need to look in the positive section. We get about, it's between these two numbers, but I'm just going to use this number here. So 1.64. So our z critical is approximately 1.64. So we'll say approximately. So we got our critical value. Now we need our test value. So we need to calculate the z test, which means we need to calculate our p hat. So our p hat here, they said that 200 lawyers were in total, so that's our denominator. And 63 had some form of advertising. So 63 out of 200, which is so half of 63 is about 31.5. So this is 0.315. All right, so now we got our p hat. We need to find our q, which is 1 minus p. So that's going to be 0.75. So now I'm just going to plug in the numbers into the z-test and get the actual value for the z-test. All right, so I went ahead and I plugged in the numbers and I got 2.12 for the test value. So we got step 4, we need to make a decision. So we're going to quickly draw the curve here. So we have just a quick sketch here. So in blue, we're going to do our test value, 2.12. And our critical value is 1.64. So we're going to shade to the right. And looks like we are in our rejection region, so therefore we are going to reject. Or null. So step 5, there is enough evidence. At the 5% level, and our claim belonged to our HA, so we're going to use the word support. So to support, the claim that, now if you look back to the problem, the claim was that there that more than 25% of all lawyers advertise. All right, so for the p-value method, we just repeat what we did for the traditional method. Step 2, we report our test value, which is 2.12. Step 3, we need to find our p-value. So we draw a curve, and we label our z test, which is 2.12. So 2.12 is around there. And since we are doing a right tail test, we are only shading one region. We're not doing the negative 2.12. And then we look up the region. So we need to look up this region here. So when we look it up, remember that the z-chart only gives us the left area. So if we need to find the right area, we need to do 1 minus. Okay, so the p-value is 1 minus the area that we get when we look this up on the table. Okay, so we're going to look up, of course, the 2.12. So if we go to the positive 2.12, so 2.12, that means that our area is 0.983. But of course, that doesn't make any sense because this is a small area, which is why we do 1 minus. So 0.983, so we do 1 minus that, and that gives us 0.0170. And then step 4, that number right there is less than my alpha, so therefore we reject. So step 5, is a repetition of step 5 earlier. All right, and that's our solution to the problem. So we ended up having enough evidence to reject. All right, guys, that's going to do it. I hope this proved useful, and I will see you in the next video.